Okay, so for the second part of 8.5, we're going to do some problems that involve the natural log and some where you have to do some condensing to be able to solve. Okay? The main rule I said last time, logs go to exponents, exponents go to logs. So even if you're dealing with the natural log, it's the same concept. Okay? E to the 2x equals 32. I know the base is an e, which kind of throws people off a little bit. It's still an exponent. Write it as a log. Okay? We're going to write this as log base e of 32 equals 2x. And what you have to remember is how else you can write log base e. Log base e is nice because it's a function that is right on your calculator that you can plug in. ln 32 equals 2x. That's something you can plug right into your calculator, and you should be able to get 3.466 equals 2x. And now you just got to get the x by itself by dividing. Divide by 2, and that ends up being 1.733 equals x. Sorry, I almost forgot my equals x there. Okay. Even though it has the e, it's still an exponent. You write it as a log. Now here we have natural log x plus 2 equals 3. So instead of going from log base e right into ln, I'm going to take that ln and I'm going to write it as log base e. Log base e x plus 2 equals 3. It's a log function. When it's a log function, write it as an exponent. The base is e to the third power equals x plus 2. That you can plug right into your calculator. You should end up with 20.086 equals x plus 2. Now just subtract your 2 from both sides. 18.086 equals x. Okay? I mean, I'm checking my answers. I haven't written on the paper. They're not going to be nice looking answers. I don't expect you to be able to do e to the third power in your head. You have a calculator. Don't expect you to do natural base log of 32 in your head. Use your calculator. Those functions are on there for a reason. Okay? Same concept. Log, wrote it, or sorry, exponent wrote as a log. This was a log, wrote it as an exponent. Now here we have log base 2 of x minus 2 minus log base 2 of 3 equals 4. What a lot of people want to do in this problem is bring this log base 2 of 3 over, add it to both sides, and they think the log base 2 and the log base 2 would cancel each other out. The issue is that 4. Okay? When there's other things involved here, and there's other pieces, you can't just cancel them out. That problem we did in the other video, those were the only pieces. You had one log on the left, one log on the right, and then they were able to cancel out. There was nothing else involved. What we're going to do here is use our properties of condensing. Okay? We're going to get it down to just a single log. Log base 2 x minus 2 minus log base 2 of 3. That minus, think about what property that is. That is the quotient property. So we can rewrite this log as log base 2 x minus 2 over 3 equals 4. And from there, it's our normal problem. It's a log. Let's write it as an exponent. 2 to the 4th power equals x minus 2 over 3. And this we should be able to solve. 2 to the 4th power should end up giving you 16 equals x minus 2 over 3. And again, that's an equation you should be able to solve. Multiply 3 on both sides. 48 equals x minus 2. Add 2. And we get x equals 50. Okay, just want to check my answer there. Yep, x equals 50. Here we have 2 log base x minus log of 4. Sorry, let me say that again. I threw base in there. 2 log of x minus log of 4 equals 5. So again, with that 5 over there, we can't just cancel out our bases, even though we have no base. It's the common log, so base is 10. Okay? You can't just cancel them out because of that 5. We can condense. We can bring that 2 as an exponent. We have subtraction again, so again it's going to be the quotient rule. So let's write this as log x squared over 4 equals 5. Now let's remember, if you don't see a base, the common log, the base is going to be 10. Okay? So if we write this out, we are going to have 10 to the 5th power equals x squared over 4. Now you just got to be able to do 10 to the 5th power. That should be 100,000 equals x squared over 4. All right, some big numbers here. Okay, 100,000 multiplied by 4 gives us 400,000. And square root that. Cancel out the square there. And the square root of 400,000, if you want to do a factor tree, you can. That would end up being at 200. Square root 10, don't forget your plus minus. Okay, if you wanted to get the exact answer, you can give me decimals, and that ends up being 632.456, and again, don't forget your plus minus. Either one of those answers will be accepted. Okay? So this was some problems, examples of how you use the condensing properties to solve. Okay? So that's the end of section 8.5.